This is a very interesting question under moment of a force. It says two masses, 40 gram and 60 gram respectively, are attached firmly to the ends of a light metal rule. The center of gravity of the system is, these are four options to choose from. Let us dive right into it. It is very simple, but it's quite interesting. This is the scenario painted out here. 40 gram and 60 gram masses are firmly tied or attached to the ends of the meter rule. In physics, or generally, the meter rule is 100 centimeter in length. One is at one end, 40 gram, and the other is at the other end, 60 gram. We are looking for the center of gravity of the system. The center of gravity of a uniform material such as this is usually at the center of the object. But in this case, the addition of these masses now makes this ruler not to be balanced at the center, but we don't know where exactly it's going to be balanced, which is the center of gravity. So we are going to assume that this point is going to be the center of gravity, where the meter rule is going to balance with these masses added at either ends. Now we want to check the distance this must be for the masses to be balanced, or for the meter rule rather to be balanced. That point is the center of gravity. Since we don't know that point, we only assumed by placing this knife edge here, we are going to put distances between the knife edge and this mass, and the knife edge and the 60 gram mass. So let us assume that the distance between the knife edge and this mass is x centimeter. Definitely, since this is 100 centimeter for the meter rule, the length from the knife edge to this mass will be 100 minus x, because the total length is 100. Now we have successfully drawn the scenario we can solve using the principle of moment. And what is the principle of moment? This mass here will make this meter rule to turn about this point in a clockwise direction. So we can call this 60 gram mass, we can say the 60 gram mass will cause a clockwise movement, while the 40 gram mass will cause an anti-clockwise movement that will balance the clockwise movement. If that is the case, the principle of moment states that for this object to balance horizontally on the knife edge, the clockwise movement must be equal to the anti-clockwise movement. So we are going straight to calculating the clockwise movement and equating it to what we are going to get from the anti-clockwise movement. Moment of a force is the product of the force times the distance from its turning point. So for the clockwise movement will be equals to the product of the mass 60 times the distance between the mass and the turning point, which is 100 minus x. So we have 60 times 100 minus x as the clockwise movement, and that's equal to the anti-clockwise movement that balances it, which is 40 times the distance x, 40x. From here on, we can solve for the value of x. If we solve by expanding this bracket, we have that 60 times 100 is 6,000. 6,000 minus 60 times x is 60x, equal to 40x. If we add 60x to both sides, we must have taken this minus 60 to the other side, and that becomes 6,000 equal to 40x plus 60x. 40x plus 60x gives us 100x, which is equal to 6,000. To obtain x, we are going to divide both sides by the coefficient of x, which is 100. And that means that x will be equal to 6,000 divided by 100. And obviously, x is equal to 60 centimeter. It means the distance between these points where it will balance, or the center of gravity of the meter rule considering these masses, is 60 centimeter from the 40 gram mass. If x is 60, then we can say this is 60 centimeter. And if this is 60, and here we have 100 minus x, then definitely this will be 40, because 100 minus 60 is 40. So from the 40 gram mass, the distance from the knife edge, or the center of gravity, is 60. From the 60 gram mass, the distance from the center of gravity is 40. Now let's come back to the options and check for the correct answer. The center of gravity of the system is A, at the midpoint of this meter rule. Definitely it is not at the midpoint, because we have 60-40 and not 50-50. B, 40 centimeter from the lighter mass. The lighter mass is 40 gram, but it is not 40 centimeter from the lighter mass. It is 60 centimeter from the lighter mass. So B is not correct. C says 40 centimeter from the heavier mass. This is the heavier mass and it is 40 centimeter from the heavier mass. So definitely option C is the correct answer, and that gives us C as the correct answer. It is very simple, and I believe you enjoyed this and you equally understood it. If that is the case, then try this simple one here. If the clockwise moment of a force about a turning point is 105 Newton meter, calculate the force that will balance the clockwise moment, assuming the force is 15 meters from the turning point. When you get the answer, please put it in the comment section. Endeavor to like, share this video to others, and most importantly, drop your answer or whatever question you have in the comment section, and I'll be there waiting for you. Please follow our page if you are seeing our video for the first time, and continue to support Knowledge Base. Thank you very much for watching.